Today on Real Garage, I'm trying to get through some drama. And everyone knows I hate drama. So this video was going to be all about building my stainless steel exhaust, which it still is, partially. But unfortunately, I gotta unscrew some other stuff first. So I'm falling a little behind on this project, and I decided to get some aftermarket parts to speed things up a little. I got some engine mounts from Detroit Speed and Engineering for the engine combination that I'm using with their front clip. They're designed to have an 1.5 inch setback, which puts the engine about 1/2 inch to 3/4 inch off the firewall. They worked perfect. And that 1.5 inch setback is really going to help me with my weight distribution later on. The transmission mount, however, I got it from a different company, and that's another story. Let me show you this joke. So this transmission mount is designed for the F-body Camaro and Firebirds with a 4L80E transmission upgrade, which this is. So a couple of major flaws I see right off the bat. One is that it took 2 inches of spacers just to get the transmission and engine at the proper operating angle, which is crazy. Now this Certifit part, I guess, is more of a sort of fit part. Although, if you take these spacers out, the transmission mounts do line up and you can bolt it up, but the transmission and engine is at 8 degrees of angle, which is crazy. It's just ridiculous. So the second thing I see is that the mount bolts in place to the factory location, and then it sweeps back quite a ways. And even though they use 3/8 steel for this, it still has some major deflection to it. Now, I don't know about you, but I'm not putting 800 horsepower on a mount that deflects like that. So for 300 bucks, this thing's going back. So our answer to this problem is one that a friend of mine, Mark from G-Force Fab, does with some of his cars, is we're actually taking some 1/8 inch plate steel and we're plating the whole inside of the transmission tunnel here and on the inside of the car. That's going to reinforce it to the point where we can make another transmission mount here that actually will bolt directly to the bottom. And that's going to give us a ton of room for our exhaust. Warning: read and follow all labels and your owner's manuals. To cut these plates, I'm using the Spectrum 375 plasma cutter set to 27 amps. And the downdraft cabinet that I built in season 6, episode 1. Okay, a little bit of trimmage, and then shape the plate to the contour of the trans tunnel. Alright, first plate fits. Now, gotta make a bunch of plug weld holes. So, in addition to welding it all the way around the perimeter, we're making quite a few plug weld holes also. Tie this thing together. Now just under this, on the inside, is the seat pan mounting, and it's already double layer, so we're going to weld all the way around that also from the inside. But our plug weld holes will be made in our plate instead of through the sheet metal on the other side. All right, for welding this plate on, I've got my Multimatic 220 AC/DC auto set for 14 gauge. It's a happy medium between the 1/8 inch steel and the probably 18 gauge sheet metal. All right, now I'll just finish plug welding on the inside. Okay, I got my bottom side plates put in, and I made a cross brace that gets welded on the top. Then these 3/16 thick straps get welded on, and this is what actually gets welded to the transmission mount. For the 3/16 mounting straps, I've got my Multimatic auto set for 1/8 inch, but I did adjust it to max for that range. I won't be fully welding them in yet. I need to refit the transmission in place so I can figure out the location of my mounting tabs that get welded to the straps. Okay, with the trans back in the car again, I checked to make sure that it was centered, and now I can make my measurements for my bottom mounting plate, which will get bolted to the sides with some mounting tabs. So I think I'm gonna make mine 10 inches. So I'm using 3-inch wide by 1/4 inch thick cold rolled flat stock to make the bottom transmission mount. Okay, this 1/4 inch cold rolled is pretty hard to bend. So I made myself one of these little die sets here for my 20-ton press. Otherwise, the only other way you could really bend it is to heat it up and put it in the vise and beat it with a hammer. It takes pressure to bend this thing for sure. I don't exactly know the angle that I'm looking for here, so I'm just kind of sneaking up on it, you know, just check that. I'm TIG welding bolt mounts to the transmission bracket using ER80SD2 filler metal. It has higher strength than the standard ER70S2. I did a double pass with this thick material, a narrow, tight bead in the root of the joint with 0.45 size filler, and then a cover pass with 1/16 filler. That'll do, pig. That'll do. Now, it's make 4 of these mounting ears. I used the same 3/16 cold rolled flat stock for these. Basically, all I did was make a paper template, cut them out, fine tune it a little bit with the angle grinder, and then drill a 1/2-inch hole. To find my hole center, all I did was use a transfer punch. I'm running this in pretty hot on the 3/16 to 3/16. I got my machine set for 19 volts and 392 inches in wire feed speed. But when I'm doing the 3/16 to the 1/8-inch plate, then I'm back down to the 1/8-inch setting, but I turned it up to the maximum in that range. Now we can get back to what this video was supposed to be about. Now that we cleaned up our aborted plan with our aftermarket cross member, let's get back to doing the stainless steel exhaust. So after the transmission unscrew, I bolted my headers to the engine so I can start laying out my tubing in the configuration that I need. I'm using oval tubing for this project. The oval tubing is going to help me with my ground clearance. And I get my oval tubing from Granatelli Motorsports. They're the masters of oval tubing. They have multiple bends and transitions that I can use to get the configuration that I need for this project. Usually, I'll start this with an isolator joint. It's kind of a flexible joint and it does reduce some of the vibration that's felt within the car. But with the shorter wheelbase of the 69 Trans Am, I don't think I'm going to be able to fit this in. So I'm starting right with a transition, which is going to be my 3-inch round to the oval. Then I'm going into a 45-degree horizontal bend. They also have 45-degree verticals, 90-degree horizontals and 90-degree verticals. So I can pick and choose, cut and use whatever I need to go to where I need to get to. And normally I'll start my project with an X-pipe, and then I'll work my way forward to the headers and back to the mufflers. But before I get to the X-pipe, I've got a real scoop PSA for you. In this Real Scoop PSA, I want to talk a little bit about TIG welding stainless. Specifically 304 stainless, since that's what my exhaust is made out of. Now most people will TIG weld that stainless, but you also can MIG weld it. The Multimatic 220 AC/DC that I'm using actually has a program for MIG welding stainless. I'll be TIG welding most of it, and I'm using the cut lengths of 308L for filler metal, which you can also get in a reel for the MIG welder. Couple things you need to know when you're doing the MIG welding on the stainless. One is the fact that you need a different gas. It's actually a trimix. So if you change the machine over to stainless steel, it will actually tell you what gas mixture you need. That gas mixture is going to be 90% helium, 7.5% argon, and 2.5% CO2. The CO2 level should be really, really low. If you try to weld a stainless wire with a standard 75 argon, 25% CO2, that's way too much of a carbon content for that wire, and it won't have a tendency to wet out. You really need that higher helium content to add arc energy to get that wire to wet out properly. So the 90, 7.5, and 2.5 mixture is what is required for short circuit, stainless steel welding and MIG. The second point I want to make is the quality of your filler metal. Now with TIG filler, I found that most of that TIG filler is a pretty high quality, and you can test it by using a magnet. There's supposed to be lower amounts of iron and higher amounts of austenite in 300 series stainless. Iron is magnetic, so you could easily check the iron content with a magnet. Now these are high strength magnets, so you can see that the magnet is not attracted to my TIG filler. However, I was having some trouble getting some nice welds out of the wire I was using, and come to find out, it is quite magnetic. So as you can see, it's not even a little slightly magnetic, it's really magnetic, which tells me the iron content is way too high in this particular roll of wire. I don't know where it's made, but at this point, I'm gonna consider that wire junk. Now I've got 3 separate rolls of wire here from different manufacturers, and I found that 2 of them are quite magnetic, which means that iron content is too high. This roll here, this is what I'm gonna be using. So that quality of the wire is gonna really translate into the quality of your welds. Otherwise, this is what you're gonna end up with. Okay? And what happens here, if you have that higher iron content, is that this weld joint is no longer gonna be corrosion resistant. So if we take our magnet again, 304, non-magnetic, oops, weld bead, magnetic. So if you really wanna avoid ugly welds like these, check the wire quality with a magnet. For making my X-pipe, I'll trim the outside of the bend radiuses off and then weld the 2 pieces together. My goal is to get the tubes a little bit more in line with each other, but not overlapped too far. Using good quality tubing for this part is important, because cheaper tubing, when it goes through the outside of this bend radius, can become super thin and really hard to weld. I get my tubing from Granatelli Motorsports, and this bend area here is much thicker. Now it's easy to measure the thickness of your tubing with a caliper. Okay, you can just measure the end. But how are you going to measure the thickness inside the bend here? Well, you can't. So my solution to that was to buy an ultrasonic tester, which measures material thicknesses. And on the end here, the material thickness is 0.073, which is actually a little bit more than the advertised material thickness of this kit. So normally they sell this as like a 16 gauge kit, and 16 gauge is 0.0625. Now when I check the thickness of the outside of this bend radius, it measured 0.058. That's still plenty enough material to weld to. So I got my port cut in the middle here and put my 2 pipes together to form my X-pipe. Now, one of the things I like to just test out on my pipes is to see how much actual suction I have on the opposite bank, right? So what I do is just take a little shop rag, put it in that side there, and we'll actually give this side a burst of air to see how much pull I have on the opposite bank, which really proves the fact that an X-pipe does help evacuate the gases on the alternate bank. Works pretty good. So I got my tubes clamped into place. Now it's just clean it up with some acetone, tack both sides, and then re-clamp it, but I'm gonna tape off the ends and back purge it with argon on the back side. That'll keep any contaminants from flowing through the back side of the tube while I'm welding it. This video is full of useful tips and tricks. You should really subscribe. All right, so the key to getting down in this tight joint is this big gas lens and cup. You can see how far my tungsten is sticking out. And I'll put a link in the description for the part numbers for these, so they fit a standard 20 size torch. But this wider flush mounted gas lens also disperses the gas at a wider angle, so you can see my tungsten still isn't getting black or purple from lack of argon. So this is definitely the way to go, get down in these tight joints. Okay, with the X pipe finished, I've got two targets. I gotta hit the headers up front and the mufflers in the back, which are non-existent, because I wanna make some custom mufflers. Unfortunately, I don't have the expertise for that, but I do know the master of mufflers, and we'll go visit his shop on the next episode of Real Garage.